We have a guest on here, Dr. Yu. Is it? Did I pronounce that correctly?
Yes, that's correct.
Yeah, welcome to the show. I remember seeing you at Teslatech with BurnEye. BurnEye has just joined us as well.
Okay.
Oh, hello, Dr. Yu.
Hey, BurnEye.
Hi, Doctor.
Sorry about it. I did not expect this late meeting. But thank you for inviting me.
Thank you for joining.
It's great.
No,
Awesome.
no, just interrupt. Lulu, I'm just gonna scoop out and trace that APEC video from last week. You were saying just to compare what they were doing.
Okay.
Yeah, it's in the private chat, Lulu, if you want to click on the link after the show or whatever. But yeah, let's talk with Dr. Yu. And yeah, welcome again to the show.
Oh, thank you. So I just got a notice. I'm not exactly for sure what kind of topic you are discussing, but I'm willing to contribute if any questions.
Well, we've been talking a lot about electromagnetics and the Joule thief circuit, and yeah, it's right up your alley.
Okay. So if you have any specific questions about it.
Well, there was an inventor back in the early 80s. He actually was denied his patent, Joseph Newman. And he discovered that the way the electrons flow around the inductor is very much gyroscopic.
Okay.
Would you agree with that statement?
Oh, actually, I believe I discussed this one on BurnEye's show, actually. What I discovered is the so-called electron is a magnetic particle. It's not like a called a negative charged particle. So electricity is not a flow of particles. So I do not believe electron flows anywhere inside of conducting material, conductor. So what really happens is every single atoms in the conductor, they are magnetic particles. They connected as a magnetic combined connected. So like an elastic medium. So what electricity is actually oscillation. So circular oscillation due to the generator, right? Generator, you have a relative motion. So create a local excitation. So all the coils inside of the motor, inside of the generator, so because of the orientation changing relative to a magnetic field, so created the particles oscillating, and then the oscillation propagates through this called the elastic medium. So propagates. So you mentioned about the drift of electron. BurnEye mentioned about take what is it? For hours, right? Drift on inches or something like garden snake, very slow. So what I find is actually a particle inside of conducting material does not drift, no particle we call it emit from any atoms. It was actually atoms of oscillation, natural called resonance vibration. I hope that gives you some sense. So if you think about it, if you doubt it, right? Think about how alternating electricity works. You know, we call the direct current supposed to flow in one direction, right? At 70% of speed of light. Okay, so now you think about alternating electricity. So electricity, the direction of flow, changing direction 120 times per second. So basically, it's a local oscillation. It's no moving anywhere.
Right, because like Tesla kind of denounced the electron.
No kidding. That's exactly my theory. That the electron does not exist. Oh my
goodness. That makes a lot of sense, though, because that explains why electricity is so fast. When you start up a circuit, it's instant. You know, like it doesn't seem like there's any kind of, latency that you would expect with a movement of something like a particle.
It's an electromagnetic wave.
Huh.
That's
Wow.
Wow.
And it oscillates, but it propagates in a specific direction, you said.
Oh no. Oh yeah, you're right. So-called propagation. Of course, propagation along the wire, right?
Uh-huh. Wow.
If the wire connected with the other two wires, you know what happens? All the particles oscillating propagates through this conducting material, just like an elastic. Elastic medium? Just
It really makes you rethink electricity. Huh.
Yeah.
Hey, you are exactly right. I try to kill this electricity, the concept of electricity, because they are all originated from magnetic pole, from a magnetic oscillation.
Right. Doctor, just for our audience tonight that doesn't know who you are, can you just kind of briefly describe who you work for and your educational background, and just to give our audience a little bit of depth on who you are?
Oh, thank you. Give me the opportunity to familiar with all the smart people. My name called Weiping Yu. I'm currently working at NASA. I have a PhD in engineering physics, and I work for NASA almost 20 years. I'm currently is called crewed spacecraft subsystem manager. So I do oversee Starliner. That's a Boeing's spacecraft, Starliner, and Dragon. That's a SpaceX Dragon. Our flight.
Awesome.
Okay, let me add one more thing. So the reason I met a gentleman like the organizer and also BurnEye is I presented called Yuan theory of everything. It's a physical theory, and at the Tesla conference, and this theory basically simplify all the paradigm, all the worldviews. The universe is not made by dozens or even hundreds of elementary particles or multiple different forces, like 4 different forces. Those are wrong picture. I try to use my theory to say, actually, the universe made only by one single particle. Everybody knows is a magnetic particle. Do not believe anything come out of the laboratory test. Say, hey, we tested, this is called, called electron, and we discover neutron, we discover a proton, or even discover quarks. Anything come out from a laboratory, the so-called claim, no one else can cross-examine, don't believe it. What I find is electron, proton, quarks does not exist whatsoever in this universe. So that's how the physics run to the core.
I couldn't agree more with you, Dr. Yu, and I think it's why we get along so well. And it's like the particle accelerator collider, like CERN, for instance. It's like they're taking the atom, which is like the smallest actual particle, and then they're smashing it to get like into pieces, and then they're thinking that, oh, these are all these new things, when it's like, no, that's just a shard, that's a fractal piece of the original thing, right? Like
exactly, fragment piece.
Right, like you take a china, like a porcelain doll or something, you smash it on the ground, it's in 1,000 different pieces. It's like those aren't like characteristics of new things, they're just fragments of the original porcelain doll, and you're never going to figure out what the porcelain doll is by trying to find the shards and give them their own characteristics.
I totally agree.
Doctor, could you explain a little bit more about your theory on the world is made out of one particle? Could you just like go a bit into that? Not too much, but as much as you want. Let's put it that way. As much as you want. I just want to understand how you're describing it, or how you're
Wonderful. this is the key question. If you understand, so that's how I started. I started with the universe, probably from the modern physics, find out there's a total, the foundation is totally corrupt. It's a totally wrong foundation. So so what I did is try to find out. So what's the nature of light? So that's where I started. Was to find the nature of light. So I was thinking about, in order to understand what the light is, I have to understand what the smallest the particle is. So I try to find where can I find the smallest the particle. I found, okay, since the light particle we suppose called the photon, right? So I found the light is actually not a particle, it's actually the wave motion, is the medium. So I would call the you may call ether material moving, or I would call it it's a magnetic medium vibrating. So that's a light wave is the wave carried by magnetic medium. So I said, okay, let's say assuming light particle is the smallest, right? However, the medium carry light. The medium carry light. So that means even orders smaller than photon particles. So I'm talking about the particle in the medium. So that's how I started. Okay, so now I started. What is the particle, smallest particle? Make up the medium. Anything you make up, anything has to be a real matter. So that's my belief. So without matter, you do not talking about the wave. Wave means something have the carriers, right? So what material made the carrier? And I found out one and the only particle can make that one is a magnetic particle. So that's where I noticed, magnetic particle, you know the light wave called the electromagnetic wave, right? So of course the wave, so that means the carrier has to be magnetic medium. So magnetic medium vibrating create a so-called the electromagnetic wave. So that's what the light we see. So I said, okay, in order to make in order to carry light, we need a medium. And the medium, the particle made the medium, one and only is a magnetic particle. So that the magnetic particle vibrating create the electromagnetic effect. So that from that point, I find out the smallest particle is a magnetic particle. But that's not enough. I hope you follow me, right?
Yes.
Oh yeah.
Okay. But that's not enough. My theory have another half. Not only magnetic particle is the smallest one, and I prove the only particle can exist in the universe is a magnetic particle. So it's not just hey, magnetic particle is a smaller particle. You could have other particles, right? What I find, none of the other particle can exist. So I hope I can demonstrate to you. If you just give me 1 second, I'm gonna get a prop to demonstrate.
Absolutely.
Take your time. Take your time.
Yeah, to demonstrate that because this principle is so critical. If you understand this principle, you understand the entire universe, how universe operates. BurnEye,
Wow, we look forward to it.
Did I show you that one?
Yeah, this is amazing.
I'm not sure if you have yet, so I'm
I'm
stoked
gonna
for
get
this.
a prop.
Please do.
Okay, from my other room.
Okay, sounds good. And I absolutely love Dr. Yu's thesis, his science and the understanding of magnetism, and it aligns perfectly with my own model that I'm calling the VSPS fusion, or valence shell phase shift fusion. And it has to do with particles, atoms being made of the fundamental force of magnetic nuclear, and then that's the original carrier wave force. And from that, you then have acoustic, which is your sound, which is your EM wave. And then you have photon as your light. And then you have ionized plasma as the fourth field. And that it's all just waves making the field that is supposedly solid.
You know, they say virtual particles are positive and negative. So that would
Virtual.
make sense if it's a magnetic particle. It has both. You know.
Right,
That's a key question.
virtual particles. Like it's like there's not there's some particles that like don't even exist, and then there's virtual particles. But it's like it's just a packet of mathematic numbers that are these virtual packets or particles, as they claim.
Okay, so I'm gonna use this problem to demonstrate that the goal is right. None of the other particle can exist. So this is a very strict demonstration. It has to be, so magnetic particle is a fundamental particle, and it is the only particle can exist. So this is a huge claim. If you believe this one, you will understand the whole universe, how they make it. So I use this is a positron, this is an electron, suppose to positive charge particle and a negative charge particle. So why I use this one? I use this as a counter example to demonstrate how ridiculous, how contradiction, if this particle exists. So let's assuming this is an electron, the same thing works for positron. So electron defined by called a negative charged particle. So this is electron defined as a carrying negative charge. Let's assuming that's true, and I will prove that's wrong, okay? So how to do that one? So I said, okay, if this is an electron is a negative charge, hypothetically, let's split them into halves. Split them into halves. So what do I get? Bernie, can you give a guess?
You get. I don't know. Well, nothing, because it's. Or it's attractive.
I thought that this is another tricky question, right? Just one particle, right? Negative charged particle. If we split it in half.
2 half particles.
Yeah. The most logical ones are 2 negative particles. But somebody say, hey, can you split half and you get a 2 positive charged particle? That's going to violate the charge conservation. We said the electric charge is conserved. So that means you cannot turn negative to positive, right? So that's
right.
conserved.
And 2 negatives, they're going to repulse against each other, so you can't split it, right? That's where I was like,
exactly the point. Bernie, you got it.
Dipole.
So now, we cannot have half negative, half positive. We cannot that either. Also violate the charge violation. So then Bernie said, okay, only left one choice, 2 negative charge particles. However, that's the problem. If you have a 2 negative charged particle, can you form or called recombine or unified into one original particle?
No.
No,
if it's in motion, if it's in motion, it will attract it. If it's the rotation, it's going really fast.
Right.
The other one could attract it.
But if not in motion, what if that?
Well, you couldn't do it because it's 2 negatives.
Exactly. That's the contradiction. So if a negative charge particle assuming exists, then you hypothetically, you don't have the physical, you just hypothetically, hey, take a small part of one. So what that small part of negative charge will carry charge? They say, oh, carry negative charge. So then how could the negative charge in the particle and the negative to become a whole in the first place? If they couldn't, what that means? That means that this negative charge the particle assumption is wrong, so it cannot exist. So what it really is, now I try to say what it really is. So the purely positive charge particle, the same logic cannot exist. What it really is, every single particle has both negative and positive magnetic poles.
Right. So
they are inseparable. My goodness, so hey, the host, I could not see your name. What's your name?
Mike.
Oh, Mike. Okay.
Yeah.
You got it. So that means, so now let's think about the significance. The lady, you ask the most fundamental questions. I hope based on this demonstration, you understand. I hope audience understand the one things is the so-called purely negative charge particle or purely positive charge particle cannot exist because it violated Coulomb's law, like charge repel.
Right.
Okay.
Yeah.
So once you got that one, now let's see what's the significance. If every single particle is a magnetic particle, can magnetic particle orbit another magnet? So that means I try to say how ridiculous this atomic model. We call the orbital model with the electron orbiting the center of the nucleus. That model is completely wrong. Okay. So I try to explain why that model is completely wrong. Because electron, so-called negative charge particle, does not exist. And so positron does not exist. And quarks does not exist. Quarks, you carry a single charge, right? So quarks does not. So that means all these particles does not even exist. So what exists is the so-called proton and neutrons. They're all made by magnetic particles. So that means the so-called nucleus is just magnets.
Right.
Now let's see.
So
yeah, you got it.
Would it be a coherent field of energy?
Exactly. Coherent means they're all naturally binding together. Coherent. So that's exactly what the atom is. Atom is the most stable structure because all the particles are made of atom are coherent together. It's magnetic attracted together. So that's why atom is the most stable structure. I hope this makes sense. Yeah. If you get this one, you know we have to rewrite it. All the atomic model, we have to rewrite it. Every time you made an electron, you reference electron. So electrons so-called flow in the wire does not exist. There's no part in atom have any flow. So there's no such particle exists in atom in motion. It's all magnetic combined. There's nothing in motion. So okay, go ahead.
How is your peers at work feel about your theory?
Great questions. I spoke to once we have I formed a group called Kennedy Space Center Fundamental Physics Research. A lot of physics and also other engineers. After they listened to my talk, I believe that was in the 2013. Right? I almost converted all of them. So if you use your own logic, you will understand. So the so-called electron was made up, and that mistake was created by J.J. Thomson, smart British physicist, right? Experimental physicist. J.J. Thomson did called the Castle rate test, and find out, oh my goodness! So he named the phenomena. Say magnets can bending the lights inside of a vacuum tube, right? So he explained that phenomena as a electrical phenomena. So he defined the particles made up of the lines, those electrons, and the next charge electron. That's a mistake he made.
Yeah, it's kind of a misrepresentation of the actual phenomena itself.
Exactly. I don't have to explain more. Yeah.
And can you make the link with that and the quarks?
Oh, make the link to quarks. Is that right?
Yeah. Can you? Is there anything similar with that type of particle with the quarks?
Oh, sure. If you think about it, if we define quark as a negative charged or positive charged particle, fraction charged particle, that does not exist. The so-called quark are smaller fragment of magnets. BurnEye is talking about we are particle accelerator impact. You got smaller fragments, but smaller fragments It's also magnets. You know, one thing about also why is this so wonderful about the magnets? Magnets is the only particle you can subdivide it and still remain the same property. So you divide a magnet, you break a magnet, you got the two smaller pieces of magnets itself. So magnetic particle is self-similar. It's the only self-similar particles.
Right. I have a question for you. A magnet, just a regular magnet, bar magnet. What makes that magnet keep its charge and never dissipate?
Wow, you ask very deep. You know, these are the questions that I do not believe anybody solved this one yet. But let me give you my answer. First, smallest magnet. So I defined the smallest magnets called universal fundamental particle. Small, just smallest magnets. Yeah, as a natural born and carry charge eternally carry charge. So that's the natural born matter.
So it's like perpetual, I guess you could say.
The effect where we have a perpetual effect, but as a fundamental particle, I believe this is a fundamental form of matter. So every single matter. This is a good question, because if the fundamental form is not a magnetic particle, what happens? Charged particle, I just say, cannot exist. So what about a neutral particle? People say, hey, can you have a neutral particles exist? I said, you cannot. Assuming this is a neutral particle. If this is a neutral particle, how can you form a bigger particle with a basic neutral particle? Neutral particle does not have we assuming have zero electromagnetic force, right? But people say, can neutral particle have a gravity? Let me tell you, cannot. No. Or you can assume they have gravity, but gravity is zero. How do you say that one? Because if I use this one as the smaller unit of magnets, the same unit has a gravity, assuming it has gravity. So that gravity equals to 0.36 power. So that means point have 36 zeros afterwards, and then 1. So that's the strength of gravity. So that strength will not hold any two particles together. So that means if you have a neutral particle never can combine to a particle we are see. All the particles we see are combined with electromagnetic force. Without that force, particle like two grain of sand, you cannot put two grain of sand stick together. Right. Yeah. So that means those kind of matter we will never be able to see.
Interesting. Yeah, because I've asked that question to a few people, how a magnet works, and a lot of people can't answer that question. You know, how does it hold that magnetic charge in it?
I have another discovery, but I'm not even sure I wanted to disclose about how magnets works. Yeah.
Well, magnets.
How magnets work. So what is magnetic force? How can magnets work over distance?
Yeah. The magnetic force and the gravity has something in common. They both have energy, and the force is actually the energy differential. So
where you have energy, where have a differential, why two magnets has to repel or has to attract? That's
all. I'm just saying a force is the energy differential. If they attract or they repel, it's a mathematics thing, but based on that. But, you know, the gravity is a gravito-electric energy.
So I see it as gravity is an effect, and that magnetism's like the only fundamental force that everything else is built off of, depending on the motion vector. of it.
Right.
And that from there, it's like then you get electric and then you get gravity from them. So it's that's a triple dimensional vector effect rather than the force. And the force is, I guess, the distance of energy between them that you'd have.
Yeah, exactly. And the force is actually, I think it's a secondary effect from the difference in time dilation from point A and point B. They have different time dilation, and that creates a different force. You know, I think that
Do magnets work in space?
Yes. That's a great question. She basically thinks if magnets depends on matter, right?
Well,
in
no,
the
I'm thinking
space may not work, right?
Well,
Actually
I'm thinking it if a magnet it has to do with like with our physics and the rotation of the Earth and the spin vectors. Then what if it's in space? Would it work in space?
So you basically say magnetism. You are talking about you are citing the same as a traditional theory. Say magnetism is an effect of a motion of an electron or charge, right? Yeah. So you agree with that? That I believe that statement is completely opposite. This is wrong. Opposite, actually, all the electric effect is produced by magnetic poles.
Right, and that magnetism is essentially inductive and cold and endothermic, and then electric effect is the hot radiation coming out.
Oh, radiation is not an emission particle, is not a come in and come out. Radiation is a vibration of, say, electron, right? Create oscillation, and oscillation transferred through this ether medium. So you may say, hey, the radiation just a vibration of ether, or I call the ion medium, because I believe the ether is made by smaller particles of magnetic particles.
Yeah, virtual particles, which is energy.
Oh, I would not use a virtual. Virtual means hypothetical.
Right?
I'm using real particles. Yeah.
I want to just quickly interject. Like my understanding of the current model, mainstream model, where they say virtual particle, it's like, well, one, virtual means non-existent, but they believe it is, or dark matter, whatever the heck. But it's just it's a packet or a certain amount of energy,
energy,
number of energy that transfers in that interaction, right? So they're calling it a particle, but really it's just they're missing how that energy is actually transferring between one to the other, and not actually a particle.
Energy density.
What I know, like a virtual particle, it exists, but they don't know the charge until it interacts with the other one. Then they'll know if it's a positive or a negative. So it's a space of energy, but we don't know the charge yet until it interacts with the next one. Then we know if it was a positive or a negative.
It's a relative, yeah. How we detect the, what a polarity, yeah. But the word virtual give people like a hypothetical is some kind of non-physical tone.
Yeah, it's kind of a wrong terminology to use.
Well, it's kind of correct too, because it's like there's no actual particle there. It's just an energy exchange, and it's these.
It's a coherent field of energy.
Yeah.
Yeah. It's a motion, vibration wave. Yeah.
And then how it interacts with each other, and it's the magnetism is the coherent carrier wave, and then you have the standing waves of light, of electricity, and of ionization being plasma, which then creates the field. And once you have a plasma field, you have a stable particle, is how I see it.
Yeah, that's funny. It's a good timing because that's exactly what I'm showing with the free fall experiment. That the magnetic field of the neodymium ball creates an acceleration vector that is being added to the gravitational acceleration. So that's why one ball is faster than the other one, because it has one more acceleration vector that adds to the net acceleration. So it's funny. It's a strange timing that we're talking about that.
Yeah,
So
exactly. We have the
Synchronicity, I'd say.
best guest to come on and talk about magnetism.
yeah, and Did you see my free fall experiment right before your talk, Doctor?
Mhm.
Yeah. Okay. So
you see, okay.
I mean,
Or if you want to show
So
it again.
yeah, maybe
show it
quickly show it again. So it's what
Yeah.
Phil was just doing, his experiments with dropping the magnetism.
oh, you have something
Yeah.
Yeah,
new
Phil just
phenomena
here
I
you
would
go.
like to see.
So I have a magnetic ball. I have a neodymium ball on the left, which is the red circle, and on the right it's a chrome steel ball, and
Okay.
they're both held against gravity using electromagnets. And when I cut off the current, the balls are falling down exactly at the same time, simultaneously. And you'll see what happens. Remember, the red circle is the neodymium ball, and the turquoise circle is the chrome steel ball.
Okay, I can give you prediction before you do the test.
Okay.
The magnetic balls fall slower.
Slower?
Yeah.
Okay. So I'm gonna restart. So now, one sec. Okay. So now the balls are starting exactly at the same time,
Yeah, same
the
time.
same place.
Yeah, let's see. Yeah. The free fall experiment.
And actually, the
Red seems
neodymium ball
started
is
first.
accelerating
Yeah.
faster.
Yeah.
So they're not they have the same weight at this. By the way, the weight is almost the same, so it makes no difference.
A
But
shape, size, shape the same.
yeah, so you can see that the red is winning the race here.
Yeah.
Clearly.
So if you redo this one with a higher difference, you will get a different. I believe you will get it. Oh, okay. So yours is slightly different than experiment made by a Lockheed Martin scientist. Okay.
Yeah. I forgot
Okay.
what his name.
I see the
Bushman.
difference. Yes, you're right.
Yeah, but I think it depends on the phase, because the neodymium ball either the pole faces the ceiling or the floor. I think it depends.
You are right.
It's gonna make the acceleration different.
Make an acceleration, because the one thing. So let me see. My predictions are wrong, because I was thinking about a Lockheed Martin scientist, the experiment.
Yeah, Boyd Bushman.
Yeah, Boyd
Bushman.
Bushman. Oh my goodness, you all know that one. But your test is different. So his test is falls two like pole together, right? Falls two like pole to get tied together. So create like a 3 feet each side. So totally 6 feet side of repulsive, field. And your experiment is just one dipolar magnet. So what happens is the Earth, our gravity is a magnetic force. So what happens is they adjust it to opposite pole. So Earth's pole magnets faster than non-magnetic particle. So that's why I drop fast. So I was wrong, and now I know why wrong, because I was thinking about Bush and the Bush,
Boyd
and
Bushman.
this make more sense. Yeah. Than that one.
Because when Boyd Bushman did it, he had two opposing magnets, and he had
Right.
a hole in both magnets, and he pushed them together.
Force them together. Yeah.
Right. Created this field around it.
He said that's like
Many
3 feet each side, right?
Yeah, 3 feet.
Totally like 6 foot diameter.
Right.
So that
So
created what is the diamagnetic effect, dropping.
Diamagnetic field.
Yeah. So that means that's actually for me, it prove one thing, prove existence of ether. So the
Right.
ether is a magnetic medium.
Yeah.
So that force interact with magnetic medium. So that's why slow down, right?
Now, question is for you is, as that magnet is falling, the one that Boyd Bushman did, was it creating eddy current relative to the ether?
Yes, of course. This is of course. When you have a moving magnet around the conducting material, create ether. I'm sorry, create a current.
Right.
That's you call it eddy current. Yeah.
Wow.
Yeah. So it's really a historical show tonight. No, not everybody. It's great that you are open-minded, doctor, because not all doctors are very open-minded.
Thank you. I hope you can do the same test as a Bushman, yeah, and also perform single magnets. I fall trap to your single magnets, yeah, because I was thinking about Bushman, that test.
Yeah, Bushman's.
So
Yeah.
actually, if you produce this test simultaneously, that would be a good education experiment. So I probably were stealing your idea.
Boyd Bushman actually did write a paper on it. He published it in 1996 at Lockheed Martin. So you might want to check into that. It's probably still online. You can check that out. I haven't looked into it in a while. It's been a while since I've seen the video. But he also did an interesting one with a coil of wire and hooked it up basically to the mains of the house. And it rose off the ground and just boom, like a magnetic levitation.
Yeah, sure.
The only problem with that is if you leave the power on too long, the coil burns up.
Right. You need to generate a lot of high voltage power, right? Yeah. So I try to make some called a hover graph. Need high voltage, minimum of 15,000 volts or something.
Wow.
And actually burned those supporting stuff, spark.
Now, if you're dealing with that high voltage, do we have to worry about the radiation coming off that?
Yes.
Is there a radiation factor there? So that would be another issue. One thing to make it actually work, but is it actually safe to actually be around it? And that's what they're saying about some of these UFOs. People get really close to them, they get radiation burns.
Exactly. That's what I believe so. They are powered by anti-gravity, actually due to anti-gravity, that's an electromagnetic wave, opposite to gravitational polarity. So that's why can make them instantly acceleration almost, right? Yeah. Repel.
Right.
Yeah, yes. I do believe.
I can't imagine the amount of force that's involved in that. Must be enormous to create that effect. And one thing, be around it when that's happening cannot be good for you. So to make a craft like that, you would have a device where you have to shield yourself greatly to be even around that field.
Yes.
Oh, exactly. It's why I have not produced or conducted probably 100 different experiments that I'm planning on of increasing magnitude by combining more voltage, so then I get a plasma arc into my electrolysis reactor, or putting in the acoustic sound waves into that for the sonoluminescence aspect, right? Where when you combine certain thresholds of magnitudes of energy into it, you're going to then have these exponential gains in energy interactions as the outcome as well. And that's why so many people struggle with believing my claims with hydrogen and electrolysis and stuff, because they're like, how have you not blown yourself up, BurnEye? Or with specific aspects of transmutation within the electrolysis reactors. That it's like I did it once when I was first messing around, and sure enough, there was radioactive parts that formed, and I got very sick very quickly. And then I realized what was going on. And then since then, over the last 15 years, I've never crossed those thresholds again until I have the safe space, the safe lab to do it, and to risk contamination, to be able to be shielded from radiation, or well ventilated, where I go over 5 volts of electricity in myself running electrolysis reactors, and put in maybe 15,000, and all of a sudden the room would blow up from the amount of hydrogen that's coming out of it, as opposed to just small little amounts that are able to evaporate into the air.
Yeah, exactly. There was some experiments that I did with the Don Smith device, dealing with high voltage and coils and stuff like that, and spark gaps. I kind of backed away from it because at that
You're
time
experiencing time dilation, which has time radiation effects, and that's the
yeah.
thing, that there is what should be called essentially time radiation, or it's the differential when you're having time. I guess
it's not the problem is not
nothing.
The problem is not time radiation. The problem is the power. The frequency is too high. You're gonna have a side effect, which is high time dilation as well, coming up with it. But the real problem is the high frequency in the first place that creates the radiation. You know what I mean?
Yeah.
Time dilation is very safe.
Yeah,
but
like when I did my experiments, whether it was digital or analog, the time was slowing down when I did my experiments.
Yeah, that's cool.
How I did it was I had 2 very strong neodymium magnets, north poles facing out, spinning on a shaft, okay, at about 4,000 RPM, and I was hitting it with 11,000 volts. And when I did that, my clock started changing.
Yeah, that's cool.
Yeah, it didn't matter if it was analog or digital; they all started changing.
Great Scott! That's what I have to say.
See, my question with time dilation is, when we conduct these experiments, what happens to the outside world in comparison to, our time zone? How does it reconciliate?
Well, you're gonna see the outside world on fast forward.
No,
and the outside world will see you in slow motion.
The biological, physical aspect of matter. That's where I'm talking about there being this time radiation aspects of it. That when you're essentially engineering, ripping apart space-time, the fabric of space-time itself, to get through one to the other, that as the rest of the space has to catch up with the time that you've gone through or maneuvered, that it does a bit of decay or addition, I guess, growth into the matter around it.
Okay, hypothetically, you conduct this experiment and then you go to your work. Do you incur traffic to, take the time for everybody else to catch up? Or are you faster in space and time and the universe doesn't, and you get there?
It's like in The Matrix. Remember the movie The Matrix? When he slows down time and then dodges bullets and things like that. It's actually the same thing. You perceive the external world either in slow motion or in fast forward, and the external world will perceive you exactly the opposite.
Yeah. So, question, like, let's say we have a clock though, and our local clocks, is ticking this way. What is the surrounding clock, what would that be? Like how does that reconciliate at one
Universal
point?
time.
Okay.
Universal time. See, the experiment I did, Doctor, was based on Dr. Bruce De Palma. He was a MIT professor, and he was spinning magnets like my experiment. And when he put the clock on the axle, just above the axle of the spinning magnets, the clock starts slowing down. So he's actually a doctor himself. He's a former MIT professor back in the 75 time frame, 1975. And he built the first device, I believe, around 1979 and proved by spinning magnets. And if you put the clock above the shaft of the spinning magnet, time slows down. So he was seeing a fluctuation of time dilation there just by spinning a magnetic field at a very high RPM. So
Yeah, so yeah, you already have the energy of the magnetic field, and you add gravito-electromagnetic energy to that, so it all contributes to the time dilation.
So, Doctor, what do you think about that experiment that Bruce De Palma did on the spinning magnets? Do you have any comments on that?
Or time dilation in general?
I do not familiar that spinning magnets. Actually, I actually do not believe time dilation, length contraction, and the mass inflation. I believe that's the mistake.
Yeah, I agree with you that length contraction and mass increase is nonsense. They were never proven.
Right.
But time dilation is, I think it
Some
makes more sense.
Yeah. So my question is, you said the spinning magnets.
Right.
So how do you know time slowed? Is that because the clock slowed down?
Yeah, the clock was slowing
down.
Okay.
So that's a physical because of magnetism add extra, changing the material property, magnetism. So that's why mechanical clock will be impacted. But that's not due to time dilation due to relativity effect. That's not a relativity. That's just like a gravity. At a different height, gravity you clock running at a different time. That's because of gravity just like a magnetic. Gravity is magnetism. Okay, in my theory.
Yeah.
So that's why you said the spinning magnets will impact all the functions, materials surrounding it, including biological beings.
Yeah, my magnet is gravity because force is a energy differential. It's very simple. Same thing.
I hope I answered your questions, right? I believe
great,
a clock.
Doctor.
Yeah, clock impact, not a real time impact.
We're at the top of the hour. Thanks a lot, Dr. Yu, for coming on and our whole panel. We go live to air again every Friday at 9 o'clock Eastern, 6 o'clock Pacific. And again, any questions, comments for the panel, you have BurnEye's email address. You have my email address. You can make comments on the YouTube channel Faraday Research and also BurnEye at Crypto Alchemist. And we'll see everybody next week.
And if you want to stay around for a minute, Dr. Yu, after we're live to talk, feel free.
Okay, sure. I can stay on a little bit longer.
Thanks a lot, everybody.
Thank you, Mike. Thank you.
Awesome. Thanks.